All right, here we are tonight. We're going to learn about absolute value equations and inequalities. Some of you already started this in class, and what I would definitely recommend is that you at least review this video as much as you feel totally comfortable with so that you're ready to do an activity on it in class tomorrow. So let's just remember that absolute value are these little lines. And if I put a number inside of it, what I'm looking for is how many places from 0 is 2. So absolute value is the distance that a number is from 0. So you can just say absolute value is the distance from 0. That number will always be positive because I can't get in my car and drive -2 miles. Okay, so that's just kind of the practical aspect of it. Okay, so let's go ahead and we're going to start filling in these blanks. Both 5 and -5 are solutions to the equation the absolute value of a equals 5. Because if I put a 5 in, the absolute value of 5 is 5, and the absolute value of -5 is also 5. And for that reason, many absolute value equations have two solutions. If I have an equation like the absolute value of anything is equal to a negative number, then we say that it has no solution because you cannot have an absolute value equal to a negative number. Now you can have like an equation with some other stuff on it equal to a negative maybe, but you should never have just absolute value bars equal to a negative number. So let's go ahead and look down at example 1. So here are my absolute value bars. It's not equal to a negative number, so what I'm going to do is I'm going to take that stuff that's inside, so t minus 7, and I know that t minus 7 could equal positive 8, and I also know that t minus 7 could equal negative 8, because the number inside of the absolute value bar could equal 8 or negative 8. So you set the two equations up, and they've done that for us down here. So now I'm just going to solve like normal. So I'm going to add 7 to both sides. When I do, I'm going to get t is equal to 15. So one of my solutions is 15. And then on the other side, I'm going to add 7 to both sides. And t is equal to -1. So my other solution is -1. And for this line right here, you're going to write the absolute value equation as two equations, and they're actually like opposite equations. So remember, you have the positive equation, positive 8, and you have the negative equation, -8. All right, let's look at the problems. So now I have an absolute value, but I also have, so here's my absolute value, I also have them adding 25. I have to isolate or get the absolute value part by itself. So this is considered like our constant, and all of this absolute value bars are kind of like parentheses. So all of this absolute value part you have to get by itself first. So I'm going to isolate the absolute value. So what I'm going to do is I'm going to subtract 25 from each side. And when I do, I'm going to get the absolute value of 5p is equal to -10. Now, can I drive absolute value -10? No, I cannot have a negative value, so there is no solution. Now remember, that is the exception, not normal. So it happens, but not that often. Okay, so here's an example, an exercise. I'm going to take this m plus 8, and I'm going to split it into two inequalities. So the first one will say m plus 8 equals 5. But we also know that m plus 8 could equal -5. So all I did was I did a positive and negative answer. And then solving these are usually really simple. So when I subtract 8, I'll have m is equal to -3. So that's one solution. When I subtract 8 here, I'll have m is equal to -13. There's the other solution. So two solutions most of the time. Okay, let's look at the second one down here. So again, this is my inside the absolute value part. I don't have anything outside, so I'm going to go ahead and split this in half. 3b minus 1 is equal to positive 11, and 3b minus 1 is equal to negative 11. Oops, negative 11. So here I'm going to go ahead and add 1. Add 1. So I have 3b is equal to 12. Divide by 3. And I will end up with b is equal to 4. Sorry, I had to squeeze that in there, and I'm going to circle my final answer. Then I'm going to add 1 on the other equation. So I still have 3b, and negative 11 plus 1 is negative 10. When I divide by 3, I can't simplify that, so my other solution, I have to go up here, is b is equal to negative 10 over 3. So you do have a fraction answer, but that's not a problem, and notice you have two solutions, which is totally normal. Okay, so remember we did 1 and 2 on the last page, so now we can go ahead and look at number 3. So here's my absolute value bars. Oh look, they're adding on or subtracting this 25, so I have to isolate the absolute value first. I have to get the absolute value by itself. So I'm going to get rid of this minus 25 by adding 25. Okay, so the absolute value of y plus 17 comes down. Negative 10 plus 25 is 15. That doesn't weird me out. And now I have absolute value equal to a positive number, so I'm going to go ahead and split this into two equations. Y plus 17 is equal to positive 15, and y plus 17 is equal to negative 15. And then I will let you go ahead and solve those. On the last one, it's very similar. So I look here, I have these absolute value bars, and look, oh, they're adding on a 7. So I have to isolate the absolute value bars first. So I'm going to subtract 7. So I have the absolute value of 4s plus 1 is equal to negative 2. Can I have an absolute value only equal to a negative number? No. So this one is your one and only no solution. You can't have absolute value bars equal to a negative number. So there's your no solution. Okay, on the back side. Now these look kind of confusing, but they're actually pretty simple. So if I have the absolute value is less than 5, I'm going to go ahead and write that normal. So I have a is less than 5. And then I'm going to flip it, or then I'm going to change it to negative 5. But when I make it a negative 5, I also have to flip the inequality. So basically you're going to flip the inequality, and now you have this. So on this one I'm going to have a is greater than 5, or if I flip it, I'm going to have a is less than negative 5. So you flip the inequality when you change the sign. So here are my two equations. See how they took the 2n minus 3, and they said is greater than 9, and they said 2n minus 3 is less than negative 9. Okay, so I just paused the video because I noticed some sort of strange mistake. I got this worksheet from your book, and somehow when the printable copy has a mistake in it, the other copy is fine. This right here, they just typed it wrong. So if you were confused about why it became a greater than positive 9, it's because this is wrong. It should be a greater than or equal to 9. So I'm not sure what happened on the printable copy, but that is wrong. Okay, so now I'm going to go ahead and I'm going to solve this. I'm going to add 3 to both sides. So now I have 2n is greater than or equal to 9 and 3 is 12. Divide by 2. And n is greater than or equal to 6. And then on the other side, I'm going to do the same thing. I'm going to add 3. So here, 2n is less than or equal to negative 6. Divide by 2. And n is less than or equal to negative 3. So now I can go ahead and graph these. So I'm going to put negative 3 and I'm going to put positive 6. Both of them should be a solid dot because I have the line underneath. And I want the ends that are bigger than 6, so that goes this way. And I want the ends that are smaller than negative 3, so that goes this way. And you'll notice that this is an OR inequality. So if it starts out with greater than, it's actually an OR inequality, and if it starts out with less than, it's going to be an AND inequality. It's not essential that you remember that part because you'll always get that when you do the problems. Okay, I'm just going to do a couple of these before my time runs out. So I have the absolute value of x minus 3 is greater than 5. So I'm going to take what's inside, x minus 3, keep the greater than 5, and then I'm going to take what's inside, x minus 3, but this time I'm going to flip the inequality because I also am going to change the sign. So I flipped the inequality when I changed the sign. Then I'll go ahead and solve. I'll add 3 to both sides. So I'll have x is greater than 8. I'm going to add 3 to both sides. And I'll have x is less than negative 2. And then you can go ahead and graph both of those. All right, make sure you bring your questions in tomorrow, and then we will answer those before you have an in-class assignment.